All right, so on number 1, the vertex is shifted, right 3, down 2, right 3, down 2. Now there's an understood positive 1 out in front, so if we thought about this problem in terms of slope, it has a slope of 1 on the right side. Up 1 over 1, up 1 over 1, up 1 over 1. If you thought about it in terms of moves, the moves are normal. The absolute value of positive or negative 1 is 1. The absolute value of positive or negative 2 is 2. The absolute value of positive or negative 3 is 3. You can think of it either way. Now, if we're doing slope, on the right side, we do it there. On the left side, we do the opposite of that. Okay, now once we have this graph, how do we answer the 2 questions you're given? The first thing you're asked is, where is the function equal to 1? So that would be the blue line. Okay? Where is the function equal to 1? So we're looking at where it's exactly equal to. And it is equal to right here with an x value of 0 and right here with an x value of 6. Does that make sense? Okay, the second question relating to this function is an inequality. Now, with an inequality, we do the same thing with a graph. You would graph in or think about a horizontal line right here at a y value of -1. So where is it less than that? The less than is below. So on this graph, what are the x values that are less than -1 from here to here? So that is from 2 to 4. All right, number 2. We're going to shift right 1, up 2. So that gives us the vertex at 1, 2. That's where we start, 1, 2. If we think of it in terms of slope, this is a -1/2, which means down 1 over 2, down 1 over 2, down 1 over 2. Opposite on the other side, down 1 left 2, down 1 left 2, down 1 left 2. So if you think about it in terms of slope, that's what it looks like. If you think about it in terms of moves, plus or minus 1, 1, but this time we have to multiply by 1/2. Actually, -1/2. So we go left or right 1, down 1/2. Left or right 2, 2 times -1/2 is down 1. Left or right 2, down 1. You get the same thing. So whichever way you're more comfortable with. Now this one, where is this function exactly equal to -1? So I'm going to just pull this over here, stretch it out a little bit. So what are those 2 x values where it's exactly -1? The x value here is -5. The x value here is +7. So what that means is if I plugged in -5 or +7, what value would I get out for d of x? -1. -1. That's where it equals -1. Okay, the next one. Where is it less than 1? All right, so I'm going to shift this up to 1. Do we see it is less than 1 over here and over here? So from -infinity to this x value of -1, and then again from 3 to +infinity. Any questions? Okay, you're making corrections? I have a feeling we'll probably have our first notebook quiz coming up shortly. Make sure you bring your notebook every day.
After we do that, can you take out a big section of
Sure.
Okay.
Yeah. It's only going to start with chapter 2. Unit 2. So if you want to go ahead and take some unit 1 stuff out and leave it in your locker or leave it at home, that's fine. So it'll only start with unit 2. Okay. This one we graph, and then we want to know where it exactly equals -4. Woo! What are the x values right there? -3 and -1. Where is it greater than -2? It is above over here to this x value. So from -infinity to -4, and then from 0 to infinity. All right, a little bit of detail here. I want you to notice no equal to, no brackets, just parentheses. Equal to, brackets.
So wait, which one was that says greater than or equal to -2? Wouldn't that would be all absolute numbers? Or
Okay, all right, so what you're saying is this function is greater than -2, And you have to get it in the right form to be able to make those statements, okay? So what we would have to do algebraically to do that is move this 6 over, and then you're going to notice it turns positive. So, yeah. So, if this was just an absolute value in this number, you're right. And what that would mean is the entire function would be up above the x-axis. Yeah, that's what that would mean. Okay. So, I actually want to do these with you guys. So let me go pull up today's. This was day 8. Okay. Okay, so now you're asked to solve. I told you some steps yesterday in solving. So step 1 is to isolate your absolute value. Get your absolute value completely by itself. So when we do that, in this problem, it's just moving the 2 over, right? So then we have isolated our absolute value. And this is where we do look at it. This has an absolute value equal to a positive number. Is that something that's possible? Yeah, absolute value can equal a positive. If at this point we had an absolute value equal to a negative number, you don't have to solve anything. What would you write? No solution. Okay, so once we isolate our absolute value, that's when we try to identify, is this problem possible? And if we say yes, then we keep going. All right, so we know that all of this stuff can either equal positive 6 and make a true statement, or all of this stuff could equal negative 6, because what is the absolute value of negative 6? 6. So we set up those two situations. X minus 3 equals positive 6, or x minus 3 equals negative 6. And we solve them. So we just add 3. And we get x equals 9, or we add 3, negative 3. And that's it. So for absolute value equations, we get 2 answers most of the time. Here's one situation where we get 1 answer, and I have it here on the board. It's where we have an absolute value, and when we isolate the absolute value, if it equals 0, then there's only one solution.
Can you do them or 11?
I'm doing them all right now. Okay. Number 8, we're going to isolate the absolute value. So we're going to move the 2 over. Then we're going to multiply by 3. Not multiply, divide by 3. All right. I get the absolute value of x plus 10 equals 5. Well, this is something that is possible. It's possible for an absolute value to equal a positive number. So at this point, this is where I split it into the 2 possibilities. Either x plus 10 can equal positive 5, because the absolute value of positive 5 is 5, or x plus 10 can equal negative 5, because the absolute value of negative 5 is 5. So I solve both of these possibilities, and I get x equals negative 5, or negative 15. So if I plug in negative 5, I get positive 5, absolute value of positive 5 is 5. If I plug in negative 15, I get negative 5, but the absolute value of negative 5 is 5. So both of these work. Okay, now this one. I subtract the 8, and I get the opposite of the absolute value of x minus 1 equals negative 6. Well, if this negative out in front wasn't there, this would be a no solution. But it is there. So we have to divide both sides by negative 1, and then we are left with something that is possible. It is possible for an absolute value to equal a positive number. So now we separate it into our 2 possibilities. Either this equals positive 6, or all of this can equal negative 6 to make a true statement. And so we add the 1, and we get x equals 7, or negative 5. right, any questions about 7, 8, or 9? Yes, sir?
Number 9, when you divide it by -1, did that change the sign?
If it's an inequality, it does, but with an equality, it does not. So if this were a less than or greater than, then yes, we would definitely switch the inequality. Okay, so let's take a look at the next group. And these are the more interesting ones. And yesterday we just talked about one way to write your answer. Today we're going to talk about 2 other ways. They all mean the same thing. We're just going to talk about some different forms. So for this one, when we isolate the absolute value of this inequality, all we have to do is add 6. Now with an inequality, if I ever have to multiply or divide by a negative, I switch the inequality. But I didn't have to multiply or divide by a negative, so this inequality stays the same. Now this is where you ask yourself a question. Is it possible for an absolute value to be greater than a positive number? Yes, that's a possibility. Okay? So, since that is a possibility, now we have to set up our 2 situations. Either all of this is greater than 8. Now, another thing I want to talk about that I didn't stress yesterday. Yesterday was kind of a preview day. Greater gives us an or situation. Less than gives us an and situation. Okay? And if it helps you, you can just spell it wrong. Call it great or and less than. So, greater gives us an or, and we'll talk about what that means in just a second. So this is greater. So this is going to give us an or situation. Now, the first one stays exactly the same. The second inequality, we switch 2 things. We switch the inequality and we change the sign of the number. And the reason has to do with that negative. Multiplying by negative, what does it do? Changes it. So if we turn this into the -8, it switches it. Okay, so these are our 2 possibilities. And we solve them. We add 5 and we add 5 and we get x is greater than 13. And I said this is an or situation, and we'll see why in just a second. We add 5 and we add 5 because here we get x is less than -3. Is it possible for a number to be greater than 13 and less than -3? No. That's why greater ends up being an or situation. It's either going to be greater than 13 or less than -3. Okay, so that's what it looks like as an inequality. This is our inequality statement. Now, if we were to graph this on a number line, and part of the reason I do this, guys, is because on the SAT and ACT, they may give you 4 number lines to choose from after solving an absolute value inequality. They may not give you inequality notation. So, what would this look like on a number line? All right, if you guys remember from doing our number lines, you probably haven't done them since Algebra 1. If it doesn't have the equal to, it's an open circle, right? And this is all the x's are bigger than 13, or greater than 13, so that would shade this direction, correct? And then this would be an open circle on -3, and this has all the answers are less than -3. So this would go this way. Okay. I would like everyone to please add the number line option. I know I didn't give you enough space. When I was checking their homework, I was walking around going, they don't have enough space to add what I want them to add. Okay, so that's what it looks like on a number line. And those of you taking the PSAT next week, you may see one like that. You may not.
And then isn't it, there's a line fill in the circle?
If there's an equal to, yes, it would be a filled-in circle. And we have one of those to do next. All right, so that is another form of an answer for this inequality. It's using a number line. Okay, the third possibility, and we've used this a lot, is the interval notation. And it's really easy once we have a number line because, look, this is going forever left, which is negative infinity, up to negative 3. Does it include negative 3? Does it? Is it filled in? No. Okay, if it's filled in, bracket. If it's open, parenthesis. Open, parenthesis, because there's no equal to. No equal to, parenthesis. Equal to, bracket. Okay? And then we have another interval that goes from 13 to infinity. So these are actually 3 possible forms for your answer. As an inequality, okay, so that's this. As a number line, or with an interval. And so today, on the back of our worksheet, we are practicing solving absolute value inequalities and equations. When we get to inequalities, I want to see all 3 forms. I want you to practice that. So when we get to our quiz Friday, no matter which form I ask you for, you'll know how to do it. Okay, so number 11, we subtract 8. And then we have negative 1/3 comes the absolute value of x minus 1 is greater than or equal to negative 2. Okay, we still haven't isolated the absolute value. So in this one, we have to multiply by a negative 3. All right, I'm dealing with an inequality, and I had to multiply by a negative. What does that do to my sign? It's going to make this part positive, and what does it do to the inequality? Switches it. If you multiply or divide by a negative, it switches that inequality. Now, is it possible for an absolute value to be less than or equal to 6? Yeah, because there's some positive numbers less than 6. So we can still keep working. This one will solve. So we'll split it up into x minus 1 is less than or equal to 6. Now this is less than. Less than is a and. And you'll see what that means in a second. And then x minus 1 is greater than or equal to, because we switch and change the sign, negative 6. So to solve this one, we're just going to add 1 to both sides. So we get x is less than or equal to 7, and add 1 to both sides. X is greater than or equal to negative 5. Any and can be written as a compound inequality. So we always start with a lower value to the upper value. Because this says my answers have to be less than or equal to 7 and greater than or equal to negative 5. They're in between. They're in between negative 5 and positive 7. And the compound inequality makes you see that pretty easy. Doesn't it look like x, which represents all the answers, is in between those two? So with a compound inequality, you always go your lesser value. It's either less than or equal to x, and then your greater value. It always looks like this. Whenever we have an and, we have a compound. This is the form. Okay, so last night you probably just left your answer like that. X is less than or equal to 7, and x is greater than or equal to negative 5. You probably didn't even have the word and, because I didn't talk about that yesterday. Yesterday we were really just concerned about the steps for solving. But today we're working on what does this mean? Understanding what the answer means. So what this answer means is that when we draw it on a number line, because we have the equal to, we're going to have those closed circles, And because it goes less than 7 and greater than 5, it comes together. And comes together or goes apart. And comes together or goes apart. All right, so the last form for your answer. So we've got, this is my inequality here. It's a compound inequality. This is my number line here. So what I'm left with is the interval. Okay, because it includes, we use brackets because of the equal to's. So it goes from least to greatest. The lesser value, the greater value. And when it comes together, it's written as one interval. When it goes apart, it's written as 2 intervals. Okay, so what I'm going to do is I'm going to make sure you got the right answer for number 12. And then I want you to show me all 3 forms of the answer. So for this one, we're going to add 2. So we get 2 is greater than or equal to 12. Divide by 2. And we get the absolute value of x plus 3 is greater than or equal to 6. Okay, so we split it. So we get x plus 3 is greater than or equal to 6. X plus 3 is less than or equal to negative 6. So x is greater than or equal to 3. And x is less than or equal to negative 9. Okay, I want you to decide, is it a or? Is it a and? Does it come together? Does it go apart? Can we write it as a compound or not? I want to see all 3 forms. I got you started with inequality. Either you decide an or goes in there and you're done, or if it's an and, you write it as a single one, and then do the number line and the interval notation. If you're not sure what you're doing, please ask for help. Okay, so we check back up to right before where we split it, where we still have it written as an absolute value inequality. And what is the sign? Oh, hold on. I do this every year. All right, everybody hold up your left hand. Form an L. We're not taking the L, we're just forming it now, okay? Rotate it. Okay, rotate it back. Rotate it back. Left hand, less than. Left hand, less than. Join me. Left hand, less. Then join me. All right. It sounds stupid, but sometimes we forget which one's less than and which one's greater than. Your left hand can only form a less than, unless you're double jointed. Then nobody wants to see it. Okay? I am, but nobody wants to see it double jointed. I show people every year. People throw up. It's not good.
Let's see it. Let's see it. Please.
All right. So less than. Left hand, less than. I can't do that. That's a greater than. Greater. Or. It's an or. It's an or. All right. So or goes apart. Or cannot be written as a compound. So this is an or. So I'm done. That is my answer as an inequality. Now let's do the number line. Okay? Less than negative 9, greater than 3, equal to. So I got closed dots, closed dots. So greater than 3 goes this way.
Would it be open?
It's equal to.
Oh, it's
Equal to is closed. Less than 9 goes left. And that's what it looks like. So it's pretty, I like having the number line to get the interval notation from. It's going left forever, so that tells me negative infinity. It's going right forever, so that tells me positive infinity. All right, so those are our 1, 2, 3 forms of the answer. Inequality, number line, interval. Okay. All right, let's take a look at that last little review part. Okay, review is important because our final can replace our lowest test grade, right? That's good stuff. That's good news. Also, there are review questions on every unit test. Occasionally, they'll pop up on some quizzes. So, all right, square root of negative 20. We're going to break that down into 4 times 5 times negative 1. The square root of negative 1 we know is I. The square root of 4 is 2. The square root of 5, we don't know, so it stays under. Okay? When we square this, 5 squared is 25. I squared is I squared. But I1, remember I to the first is I. I squared is negative 1. I cubed is negative I to the fourth is 1. I1. Okay, so this is I squared. So I squared is like multiplying by negative 1, which turns this into a negative 25. Okay, this is negative 2 times I cubed. What is I cubed? Negative I. Negative 2 times negative I is positive 2I. All right, we got to do some distributing on this one. We get 21 plus 12I plus 8I minus 2I squared. The I squared turned that into a positive 2.
This is minus 2I.
Yep, that's a minus. So when I distributed it, it made a positive 8 and a negative 2I squared. The I squared turned it back into a positive. Okay, so now we're going to add like terms. That makes 23 plus 20I. All right, here we have to distribute. So we get 14 plus 21I. And then we get negative 2I minus 3I squared. But the I squared makes that a positive 3. So this gives us 17 plus 19I. Okay, powers of I. Powers of I, we divide by 4. We don't care how many times it goes in there. What we care about is the remainder. So I to the 39th is really the same as I to the 3rd, which is negative I. All right, we multiply by the conjugate. So you get negative 6I over negative I squared. But I squared is really negative 1. So a negative negative makes a positive. And your answer is just negative 6I. And then we multiply by conjugate here. And our numerator becomes negative 15 plus 6I plus 5I minus 2I squared. The denominator, we get 25 minus 10I plus 10I minus 4I squared. Now remember, these always cancel, so you really didn't have to do both of them. You could just do the first and last, and that becomes positive. So my numerator, add like terms. Hold on. Negative 15 and 2 makes negative 13 plus 11I over 29. Okay. I'm going to go ahead and pass out today's assignment. I'm going to do 7 review, 7A, and I'm going to talk about some things that will hopefully make this a little easier. You're welcome. let me open up today's. And we're gonna scoot down to number 7. Because number 7 is kind of backwards of what we've been doing. Instead of giving you an equation and asking you to graph it, I gave you a graph and asked you to give me the equation. Okay? So what we're thinking about is, remember, your slope goes out in front here. It's going to be positive if it opens up. It's going to be negative if it opens down. And then x minus the x value at the vertex plus the y value at the vertex. So, was this one shifted left or right any?
No.
No. So, I don't have anything added or subtracted to the x, do I? There's nothing added or subtracted to the x because it didn't go back or forth any from the origin. No, it went down. 1, 2, 3, 4, 5. Where's that 5 go?
To the right of that.
Goes to the right of that. And this is 5 positive or negative?
Negative.
Negative. Okay, and now let's count the slope. Is it a normal up 1 over 1, up 1 over 1, up 1 over 1?
No.
No. What is the slope?
2.
2. That's all you gotta do. Wait. 1, 2, 3. 1, 2, 3, 4, 5. Is that 5 or 6? It's actually on 6. I can't count. I can't count. Now, to make your life easy, I want you to look at these 2 equations. There's an equation right here, matches the graph. All you have to do is answer it off the graph. There's an inequality right here, matches the graph. Okay? So, I want you to try to write the equations for 8 and 9, but it's really going to be easy to check. Because the answers are right up under it. Okay? All right, you have the rest of class. So you have about 15 minutes in class. The first part is just graphing. I did not ask you for the characteristics, so you can just graph. You don't have to give me the domain and range and all that stuff. Just graph. So that should be pretty quick. I do want you to look at the worksheet front and back. If there is part of it right now that you know you need help with, I want you to go straight to that part and ask for help.